Hello and good evening and welcome to part 2 of the MPLS Layer 3 VPN series here. During part 1 we went ahead and set up our MPLS core, and what I'm going to do right now is I'm actually going to clear this off here. So we're going to say image, where's it at? Edit, clear. Alright, get back to a clean slate. So again, we'll start off, we've got our provider, and we'll say, you know, it could be AT&T, Sprint, whomever. It could even be in your campus, right? And so this is the MPLS core, right? And we've got, this is all set up now. And so here's where the challenge comes into play, right? For service providers. So you've got, so here's where the challenge comes into play for service providers. We have customer B here and customer A here, right? So this is customer A again, and this is customer B. And so this is your provider edge router, right? And it's provider edge because it sits at the edge of the provider's MPLS network. And here are the P routers, and these are in the core. These are just the provider routers, and they create, we basically have a label switch path, or an LSP, that tells us how to go from either the ingress PE router to the egress PE router, or vice versa, right? And that's known as our label switch path, the LSP. So the challenge for the service provider is going to be, you've got customer B down here, and let's say customer B's got a loopback address that's in the 10.10.10.0/24 range, and customer A has a loopback address in the 10.10.10.0/24 range. Now they both want to send the routing information to the provider edge router so that the information can be sent across over to customer A's other site and respectively customer B, right? They want their routes to get over here. So this is where the problem is how does the provider deal with the exact same prefix from two different individuals? So one of the solutions would be that the provider puts a router here for customer B. The problem with that is that when customer C comes along, he's going to need a router. He's going to need another router for customer D. And as you can see, we're going to run into issues because you're going to need all these routers over here on this side as well. So that's one of the challenges. That's one of the challenges that the providers are going to run into is, I'm taking routes in from different customers, yet it's the same prefix. So how do we deal with that? And so the answer to dealing with that, and let me pull this off here. We'll leave this 0/24 up there. The answer to this is to basically take this router, take the provider edge router, and carve it up into individual logical routers, also known as VRFs. And we keep having these problems here with the VRFs, right? And we're going to do the same thing over here. We're going to create VRFs, and that's what we're going to do in this video. And then we're going to establish the BGP, the PE to CE routing protocols, and we're going to get connectivity from customer A's site over here, and we said that this is in Santa Rosa, California, and customer A's site out here, which is going to be in New York, right? So we're trying again to get connectivity, layer 3 connectivity between customer A's sites in these two different locations. So the first thing that we're going to need to do is we're going to need to carve up router 5 and router 9 to make sure that these routers are able to accommodate not just different customers, but are able to scale out so that we could get a ton of customers in there and get that configured. So let's go ahead and start on router 5, right? And so we're also going to talk about route targets and route distinguishers, and those are really sort of the most important part of this setup, because this is going to be how we view the routes and send them across as extended communities via multi-protocol MPiBGP, right? And that's what we're going to be using inside the provider core. All right, so let's go ahead and get started here. So we'll go from privilege exec into global config. And if I were to say IPVRF, and it's kind of pausing on me here. There we go. If I were to say IPVRF, you'll notice that I can put a VRF name in here. So this is the legacy way to create a VRF. And the reason I say that it's legacy is that creating a VRF under this, with this method, it's only IPv4 capable. And we don't want that. We want to make sure that the VRFs that we're creating are IPv4 and IPv6 capable. So the new way, right, is to do VRF definition, and then we put the name in. And so I'm going to go ahead and say customer A, right? So now once we go into the VRF sub-configuration mode, you can see that we have the route distinguisher, and it says route target, but then we have address family. So if I type do show run VRF right now, you can see that it doesn't give us much information. It shows us the definition. So I want to say address family IPv4, because I want to support IPv4 address families with these VRFs. And I'm actually going to go ahead and exit up one level, and I'm also going to say address family IPv6, right, to support both of those. So if I come back here, we want to set up a route distinguisher, right? And so this definitely deserves mention in terms of a conversation piece. So what is the route distinguisher, right? The RD. So the route distinguisher is 64 bits, right? So it's 64 bits, and it looks like I'm having some problems with the Bamboo tablet for whatever reason. So it is 64 bits. So 64 bits. And it takes the form typically of the autonomous system number and then some other number that we can define. Now, the only purpose of the route distinguisher, and this is critical, the only purpose of the route distinguisher is to do exactly what the name says, distinguish the routes to make them unique. And so if I were to say, and this is actually how we'll set up the route distinguishers for customer A, for routes that are going from this segment here, right, or from, we'll call it 15, because I'm going to use AS15, right, between router 1 and router 5. So it'll be AS15 in the BGP, the eBGP setup. So I'll put eBGP in there for the eBGP setup. So if I were to say from 15 to 93, right, or I should say 39 actually, keep the same numbering scheme, right, where you do the lower router and then the higher router. So 15 to 39. So this 32 bits over here and this 32 bits over here get prepended to the actual route 10, 10, 10, and we'll just say it's 10, 10, 10, 10, or 10, 10, 10, 0/24. And so as you can see, it's going to make this route unique, right? Now, unfortunately, BGP, without the extended community support, is unable to handle what is going to be a 64 bits plus the 32 bits, right? So we're going to have 96 bits at this point for IPv4, and for IPv6 it's going to be 192 bits for IPv6. I think I said IPv6 there. For IPv6, right? So we need to define the route distinguisher, and that's what is going to be prepended to each of the routes that, and actually, those are dots. Sorry about that. These are dots, not colons. So they're going to get prepended to each of the routes that go out via the VRF. So I'm going to go ahead and say route distinguisher on this side 15:39, right? And so at this point we've defined it as 1539, and then I'm going to go back under the address family for IPv4, and I'm going to say route target, and I'm actually exporting or converting the first video, so that's why everything's a little slow here, and that might be why we keep getting these errors. So I'm going to say route target, and you can see we could do both export or import, and I'll say both for 15:30, or actually I'm sorry, we're going to export 15:39, right? And then I'm also going to import, and I'll show you that you could type both, but I'll do import 15:39 as well. So now if I were to do show run VRF, we can see the VRF information here, but I need to exit out, right, in order for the VRF to take effect. So if I do show run VRF, so here is our VRF definition right now. So what we're going to do is now we're going to go on to interface E00, and before we do that, let's take a look to make sure we don't have any IP address information on here. So I'll do show run int E00. So we've got no information on here. So I'm going to say no shut, and then we're going to say VRF forwarding, right? And it's going to be customer A. Whoops, misspelled that. Customer A. Okay, so now I'm going to add the IP address on. So we'll say IP address, and the IP address is going to be for the PE to CE connections, we're going to go ahead and use 192. So 192.168.15.5. And we already did the no shut, so we should be good there. And then I think we're good on that interface. So we've created the VRF, and we've put the E00 interface into VRF customer A. So now this is on the PE side of the house where we're making these configuration changes. So on the customer side, if I come over here to router 1 and I say we'll go to global config, set the host name to R1, and then we're going to do interface loopback 0, IP address 1.1.1.1, and then we're going to go ahead and say router, or actually we'll leave it at that. I'm going to say interface E00. So now I'm going to configure the interface that is connected to router 5. We'll say no shut IP address 192.168.15.1. And we're going to make this a /24. So we'll say 255.255.255. And we'll give it a second here. .255.0. So now if I say do ping 192.168.15.5, do we have connectivity? We do. Now let's go back over to router 5. Let's run that same command, do ping 192.168.15.1. Now this is not going to work, and we're going to talk about why here in a second. So you can see we're getting the periods, which indicates that we don't have any connectivity. So remember, we placed the interface in a VRF, right? On the customer side, we don't need to do that. But here on the provider side, we do need to carve it up into multiple VRFs. So we've done that, but now we can't ping. What if I do a do show IP route? I should see the route for that 192.168, but you'll notice we don't see any 192s. So remember, it's in the VRF. So if I do a do show IP, and if I do a question mark, it should be VRF, or do show IP let me do show IP. Is it VRF? I'm trying to remember if the VRF is before. Yeah, VRF cust A route. And that's going to show me the VRF. So show IP route VRF cust A. There we go. So we actually have to indicate the VRF routing table that we'd like to see. And so this is how the provider can keep routing tables that are mutually exclusive between customers, right? So customer A is not going to see customer B's routes and vice versa, because they're in their own table. And it's the same thing with the ping command. So if I were to say ping question mark VRF cust A and then a question mark, I could say 192.168.15.1 and then it works, right? So we have to actually specify the VRF now going forward for the commands where we want to see information about customer A with relation to the PE router R5. All right, so we've clearly established connectivity. Let's go over to router 9, and we're going to do the same thing, right? Because we need to create the same VRF over on this side as well. So we're going to say VRF definition, and we're going to call this customer A as well. And now I'm going to say address family IPv4, and then we'll exit out and we'll say the route distinguisher. We'll use the same route distinguisher 15:39, address family IPv6, and we'll exit back out, go into address family IPv4, and we're going to say route target. And it's pausing on us here just for a second, so wait for it to come back up. There we go. So we'll say route target and export 15 : and in fact for this one here what I'll do is we'll use both and watch what happens. So when I say route target both 15:39 and then I do a do show run VRF, it actually breaks it out for you and shows you that the route target, it shows the export and the import, right? All right, so we've got the route distinguisher set up, we've got the import and export statements set up. Let's go ahead and exit out here and then exit out here. So if I do a do show VRF, you can see that the customer A VRF is set up. The protocols it supports are IPv4 and IPv6, and there's my default route distinguisher for this VRF, right? Back over on router 5, if I were to run that same command, show VRF, you can see that it actually shows me the interface on which I've applied that VRF. And so we'll see the same thing here on router 9. So let's go ahead and go into, and it's going to be interface E10. So I'll say interface E10, and I apologize that we keep getting prompted here with that. So interface E10, and I'm going to say VRF definition. Interface up, so VRF forwarding. Sorry about that. VRF forwarding, and that's going to be customer A, right? And then we'll put the IP address on 192.168.39.9. And now let's go over to router 3. And I don't think we've touched router 3 yet, so we'll go from user exec to privilege exec to global config. We'll set the host name up here as R3, and we're going to say interface. We'll get the loopback interface set up real quick. IP address. And then we'll go into interface E10, and we'll say no shut. IP address 192.168.39.3. Okay, and let's do a do ping 192.168.39.9. And let's see if we can ping the interface on R9, and we can. So if we come back to R9, we're going to say do ping VRF cust A 192.168.39.3, and we've got connectivity. So if I were to say do show IP route, we're not going to see any of the 192s in here because those are not in the global routing table. Those have been placed into the routing table. Do show IP route VRF cust A. Those have been placed into the routing table, excuse me, for VRF customer A. All right, so what we've done at this point, we've got our customer edge configured with an IP address connecting in. We've got connectivity now into the VRF. We've carved up and created a virtual router in router 5 and router 9. So now what we're going to do next is we're going to go ahead and configure the BGP configuration that would need to be applied to the eBGP configuration that would need to be applied between router 3 and 9 and router 1 and router 5, right? And actually, what I'd like to do before that, let's go ahead and let's set up the multi-protocol iBGP in the core. Let's get that done here. So on router 5, right, that's my PE router on the left-hand side of the screen. And what we're going to do now is we're going to say router BGP 59. And one of the first things that I like to do is to type in no BGP default IPv4, right? So I'm going to go ahead and we're going to use the address families all the way through here. And I believe it's going to automatically activate, but we'll check to make sure, activate the neighbor relationship. So I like to log any changes, and let's go ahead and say, and I can't, now it's kind of locked up there, so I'll leave it up there. So now what I'm going to say is neighbor, let's see if I get this, there we go, all right. So I'm going to say neighbor 9.9.9.9, I'm using the loopback address on router 9. So neighbor 9.9.9.9, remote AS 59. So this is multi-protocol iBGP. So this is going to be an iBGP relationship. And then I'm going to say neighbor 9.9.9.9, update source, loopback 0. And so here's what we're going to do now. If I do a do show run section BGP, and we'll give it a second here, what we should see is the configuration that we have to this point. And you can see we've got the address family IPv4, but we've got nothing under the address family yet. So consider this sort of the global BGP configuration piece. Now we're going to go under the address family because we need to activate the neighbor relationship. So now if I were to say address family IPv4 unicast, and we're going to say neighbor 9.9.9.9 activate, right? And then I'm going to exit the address family. So the next thing that I want to do is now what I want to do is I want to go ahead and create the VPN V4. And so this is what's going to allow us to send and receive the extended community attributes for BGP, right? For multi-protocol BGP. And the VPN V4 information that goes back and forth will be the route distinguishers and the route targets. And each of these routers, router 5 and router 9, are going to exchange this or signal each other and exchange this information so that we can find our path through from router 1 over to router 3. Right? Because right now this multi-protocol iBGP between router 5 and router 9 is being set up to facilitate the sending and receiving of these extended community attributes that we're going to be pushing back and forth. And then it's also going to facilitate the decapsulation of sort of the final step. So there'll be a penultimate hot pop that takes place with the traffic coming into router 5 and router 9. However, what's going to happen in addition to that, there's another label. It's the VPN label that gets imposed as well as popped off the label stack. It sits below the MPLS labels that get attached as it's passing through the MPLS core. And that label, when it hits the VRF, when it hits the PE router, is going to tell us which router it should actually go to, or which VRF it should actually go to. All right, so let's go ahead now. We're going to configure the VPN V4 address family. So VPN V4, and these are going to allow us to do the extended community attributes. So we'll say neighbor 9.9.9.9 activate. And so how do we tell it? How do we tell this router that, hey, you need to send the extended community attributes? So if I do send community, you can see we can do both extended or standard. So by default, it sends standard. There's no harm in sending both because we know we need the extended set and we definitely need the standard set as well. So we're going to say send community both. Right? So what does our configuration look like now? So I do a do show run section BGP. So we have sort of our global BGP config, and this establishes the iBGP peering with the other PE router. We then activate that peering relationship under the address family IPv4, and then we're going to go ahead and enable the extended community attributes or capabilities by creating a VPN V4 peering with the other PE router, right? Router 9. And so it's actually very straightforward when you look at it in the address family syntax and configuration. It's very nice to be able to pull it up like this and look at it and see and say, oh, okay, so I've got a VPN V4 peering and it's over with router 9. I can look at the global setup up top for the iBGP setup, and then I'm activating my neighbor relationships. So now there's one more thing that we're going to be doing here, and remember we have the customer router over here on the top left, and hopefully I can still write here. So let's change our color. We're going to go to blue. So over here for customer A, right? And remember, we're configuring router 5 right now. So we've created our VRF right here on the PE router. On the customer router, we're tied in, we've got connectivity. So now we're establishing this multi-protocol iBGP setup. However, we need to make sure that this VRF that's here, that VRF is also running BGP, because that's how we're going to peer with the customer edge router. It's going to be an eBGP peering, right? And we're using BGP here as the PE to CE routing protocol. So let's go ahead and we'll take care of that right now. Now we're not going to see the peering come up because router 1 hasn't been configured yet. But since we're already on router 5, let's knock that out. So now remember, we were using a VRF. So if I were to say address family IPv4, I'm going to say VRF, and now it's going to be customer A, the same VRF. And I think, if I'm not mistaken, if I were to say customer B, it should err and tell me, yeah, that the VRF does not exist. So it's nice on the latest code. It's going to catch that and tell you, hey, you're trying to create an address family under the IPv4 address family for a VRF that doesn't exist. So there we go, IPv4 VRF customer A. So how would we establish that neighbor peering? So I'm going to say neighbor 192.168.15.1 and the remote AS, and remember this is an eBGP peering and it's going to be AS15 out there, right? So I'll say AS15, and then I'm going to go ahead and activate 168.15.1. I'm going to activate that peering, right? Now again, it's not going to come up because we haven't done the router 1 side of the configuration yet. But when we get there, you'll see that it does. Okay, so let's go back over here to router 9. So let's wrap up the multi-protocol iBGP peering here on router 9. And so now when we finish this, you're going to see the peering is going to come up between 5 and 9. We're also going to be able to run a series of commands that show us the VPN V4 setup, it's going to show us the BGP peering, and we don't have any routes in there yet. So, okay, so router BGP 59, and it's the exact same process, right? We're going to say BGP log neighbor changes. We're going to say no BGP default IPv4, and we're going to go ahead and create the neighbor, 5.5.5.5, and remote AS is going to be 59. And it looks like it's pausing here on me. So remote AS is going to be 59 because it's an IBGP peering, and I'm going to say neighbor 5.5.5.5 update source loopback 0, and now we're going to go into the address family for IPv4 and say neighbor 5555 activate. And so now we've activated that activated that peering between router 5 and router 9, and there you go. We've got liftoff here. The BGP peering adjacency, and let me close this out. I apologize there. That's the video that we just finished up. It's video for phase 1. And so here we go. So we've got our BGP adjacency. It's been established, and so if I were to do show IP-BGP neighbor, you can see that, scroll back up here, you can see that neighbor 9 sees router 5, or said neighbor 9. Router 9 sees router 5, right? So BGP neighbor, there's the remote AS, right? It's an internal IBGP relationship. It's been up for 27 seconds. So we've just established our IBGP relationship. Now, but we don't have any VPN V4 support or capabilities configured yet. So we need to continue to drive on here. So let's back out of here and we'll say address family VPN V4, right? Because this is going to enable the extended communities that we're going to send. So neighbor 5.5.5.5, and actually, let me make sure over here, I'm going to debug IP or debug BGP. We'll say VPN V4 unicast, and we'll say updates, and we're going to go ahead and debug keep alives as well. All right, so we'll debug updates and keep alives for the VPN V4 family. So as you can see, it's already received a BGP keep alive there. So let me come back over here to router 9. So we're going to say neighbor 5555 and activate for VPN V4, and now we're going to tell it that we want it to send both communities, right? Standard and extended. So here you can see some information, some additional information, right? We've got the keep alives that are going back and forth, but now we're going to add in the extended community support by saying neighbor 5555 send community both. So we want to make sure that we're sending both the standard and extended communities, right? So no updates yet. Okay, so the last thing that we're going to do is the same thing we did over on router 5, is we're going to go ahead and configure the VRF that we have for customer A, since we're already here on router 9. So let me back out here. So we're going to say address family IPv4 VRF customer A, right? So we're going to create the VRF for customer A, and we're going to say neighbor 192.168.39.3, and that's going to be remote AS 39. And then we're going to say neighbor 192.168.39.3 activate. Okay, so now if I do show run section BGP, you can see that we've got our global config for BGP has been set up, right? We've got the address family for IPv4 to activate our IBGP relationship with router 5. We've got the VPN V4 relationship with the other PE router, router 5, and we've set the send community to both, so we're getting the standard and the extended communities. And then finally, we've got the VRF here under the IPv4 address family for the specific VRF for customer A, right? So for router 3. So what we need to do now is let's go ahead and bring up the BGP relationships between, and you can see we've still got the keep alives here. I don't see, yeah, nothing yet. So we haven't redistributed, we haven't done any redistribution yet between any of the routers that are involved here. So any of the customer edge routers haven't redistributed anything, and we haven't set up the BGP on the customer router. So let's go ahead and knock that out on R1. So we'll go into global config mode here, and I'm just simply going to say router BGP 15, and we're going to say BGP, we want to log changes, and now I'm going to say no BGP default IPv4, right? And we're going to add in the global setup here, 192.168.15.5, and the remote AS is 59. Because remember, this is an eBGP peering, right? So this is an eBGP peering between these two guys. Okay, so let's go ahead and go into the address family, because you'll notice that nothing has come up yet, right? So address family IPv4, and I'm going to redistribute connected. And so that's going to redistribute my loopback, and it should also, I believe it's going to redistribute the transit network between router 1 and router 5. And then the last thing we want to do to bring this all up is 192.168.15.5 activate. And what you'll see is that's pretty much it. So in terms of you can see the PE side is a little more involved. If I do show run section BGP, the PE side is much more involved, because here all we did was identify the neighbor and the remote AS, go into the IPv4 address family, redistribute connected, and then we went ahead and activated the relationship. So right now on router 1, we are done. So if I come back over here, now we're going to see the information that I was hoping that we would see, which are the routes that are being installed. So you can see that the VRF, customer A, we've got the routes being added in, right? So there's the loopback address, the 1.1.1.1/32, and it did, in fact, pick up that, it did pick up that transit network. And we've got our first VPN V4 update that's going to show me the extended attributes. So let me do a U all. Let's stop the debugging. So as you can see right here, right? So there is our route target, or I'm sorry, our route distinguisher, right? So there's our route distinguisher that makes this route unique. So 15:39, 1.1.1.1, and you can see here that's where I was crossing these guys out here, because that was obviously a mistake on my part. And then it's going to tell us that the next hop is 5555, and it's giving us a label number here, right? 508. Shows the metric, right? And then here's your extended community route target. So there is the BGP extended community route target that is hopefully going to be sent across to the other side, so that router 3 will be able to communicate with router 1. So let's go ahead and finish up here, and we're going to jump onto router 3 right now. And actually, before I do that, if I were to do here a show BGP VPN V4 unicast, I believe it's all. So you can see here that we've got our routes, right? Except we've got a rib failure here on the transit link, and that's because I don't have a network statement for this route. And this one here is actually being redistributed, and this is the best. But this is not the best because we've got a locally connected, I shouldn't say there was a network statement. We've got a better route to insert into the routing table, one that is show IP route, one that is locally connected in the VRF, right? I apologize. Let's say we'll do a show IP route VRF cust A, and you can see here that we have a directly connected route, which is better. That's why we have the rib failure. The rib failure tells us that BGP was unable to insert that route into the global routing table, and in our case, it's because we have a directly connected network with a better administrative distance, and obviously the connected administrative distance is much better than the BGP administrative distance of 20. So that's why we see the rib failure, the R here. This one here, right, it is best, it's valid, and it's best. Okay, so we've got router 5 taken care of. Let's jump back to router 3, I believe is where we were at. Okay, so we're on router 3 here, so let's configure the client side of the connection again. So we'll say router BGP 39, and we're going to say BGP log neighbor changes, no BGP default IPv4 neighbor, and this is going to be 192.168.39.9. Remote AS is going to be 59, because again this is an eBGP peering between these two guys. And then we're going to jump into the address family for IPv4 unicast, and we're going to say redistribute connected, so our loopback address, and it's going to pick up that transit network as well. And then we're going to activate that neighbor relationship, so 192.168.15.5, or not 15.5, sorry, 39.9 activate. So if I were to do the do show run section BGP, you can see there we've got an almost identical configuration with respect to what we had to type in on router 1. So let's take a look now. So we've got neighbor 192.168.39.9 is up. So if I were to do a do show IPBGP, you can see that, take a look at that. We've actually picked up our routes, our BGP routes from the other side. So right now, we should have connectivity. If I type do ping 1111, we should have connectivity, and I'm on router 3, from router 3 through the MPLS core over to router 1. So what if I were to do a trace? If I were to say do trace 1111, and this may take a couple seconds here, but let's see how it goes through. Let's see the path that router 3's traffic is taking to get over to router 1. And obviously the first hop should be router 9. You can see there's no MPLS label there, right? Because again, MPLS is not running between the customer edge router, the CE router for customer A. These are commonly referred to as CE routers, right? There is no MPLS here. It's eBGP. So it goes in to router 9. The next hop is over to router 6, and here are these MPLS labels. And now this is what's interesting, right? So you can see here it's getting sent to router 6. It shows label 600, VRF in, name and ID, VRF out, right? So label 600.508. The next hop over to router 5, Autonomous System 15, it shows MPLS label 508. So this right here is your VPN label. And that was the same label that we were notified about. If I can find it over here, I'm trying to remember where we saw that. There it is right there. So the VPN label is label 508, right? So router 5 signaled router 9 when we set up the multi-protocol IBGP relationship. And where did I trace from? Router 3. So when the traffic hits router 9 knows, oh, this is for VRF customer A. Customer A is going to get VPN label 508. You can see the experimental bits, right? 0. We're not doing anything with that. But the VPN label is 508. So that label goes onto the stack first. Then, as it gets sent out into the MPLS core, you're going to end up with label 600. Because where is it going next? It's going... Let me switch colors here. Actually, let's get a... I guess we'll do magenta. We'll give it a try. And that's not what I wanted. So let's say we'll do blue. So the trace starts, it comes down to router 9. Router 9 says, I'm going to put label 600 and label 508 on here, and I'm going to send it this way, right? So the traffic comes this way, it gets to router 6, and router 6 says, let's look at router 6's forwarding table here. So we'll say show MPLS forwarding table. So router 6 says, when packets come into me with an inbound label of 600, what do? I pop that label. So the traffic gets here, and it says it's at 600 and 508. And router 6 says I'm going to pop that label off. So that label is gone, and I'm going to forward that packet now along the way, because that's the prefix that we're headed to, or actually we're going through that sorry, I'm drawing a blank right now. We're actually going through to this router, right? And that's the next hop. So it pops it and it forwards it along, and so at this point the only label on there is 508. So then the packet shows up here at router 5. Router 5 looks at the label and says 508. So multi-protocol BGP, right? VPN V4 looks at this label and says 508. Now, where do I know that label from, right? Ah, that's right. 508 belongs to the route target 1539, the extended community 1539, which is customer A. So router 5, will then pop that label off internally, and it leaves us, we'll step back here, so you can see here, it came in with MPLS label 5 when it got to router 5. Router 5 is going to pop that off because it says, oh, okay, the VPN label is 508. I know I pop that label off. That belongs to customer A. I'm dumping it into customer A's routing table. And where does it tell me to send that if I'm going to 1.1.1.1? Tells me to send it out to 192.168.15.1. All of our labels are gone, and it's going out to AS15, and that packet ends up right here at router 1. So let's do this from the other side, right? And this is kind of where we'll cut this off, and then we're going to come back to some other, in the final video, I'll take a look at some customizations, because as you can see, right, the service provider might not want you to see all of the labeling that's going on in their environment and see all of the hops that you're taking. So let's go ahead and do this. What if I were to say trace over to 3.3.3.3? Let's see what happens, and let's see where this is going to take us. And so remember, we're going the opposite direction now. So we'll change to, red's probably not the best choice. We'll change to black. So we're now going from router 1. We're going to come down here. And in fact, let me go ahead and clear this layer real quick. There we go. So we're going from router 1. We're coming down to router 5, right? Because remember, we said trace 3.3.3.3. And so this is outstanding, right? So the first hop is, it knows, hey, I'm going to go to 192.168.5.5. So this is router 5. So it comes into router 5. Router 5 says, all right, well, I know that I'm going to go ahead and I'm going to put label 908, and I actually wanted to draw that the other way. So label 806 is going to be on the top of the stack, and at the bottom of the stack is going to be 908, right? So 806, it knows, is going over to router 8. So the packet gets here, right? The layer 2 header gets inspected, and then it looks at that first label, and router 8 says, oh, so I've got a packet, and it's coming in, and so it's an inbound packet. So what's my forwarding table say? When I get something in with label 806, what do? I pop that label, because it's going to be heading to that prefix, right, to router 9, right? Basically, it's the tunnel, right? It's an LDP tunnel through the environment. So router 8 says, I'm going to go ahead and with the 806 label and the 908, I'm going to pop off 806, and I'm going to fire it over here to its next hop, which is router 9. When the PE gets it, right, the provider edge router is going to receive it. The only label left is the VPN V4 label. And so then the provider edge router is going to look at 908, right? It's going to look at 908 here. And if we come over to the provider edge, let's see what it shows. Show MPLS forwarding table. You can see, and I'm actually glad I ran that command. I wanted to make sure I covered that. So 908, so incoming label 908, right? So he gets 908. Let me stretch this the other way. He gets 908 on the inbound packet. He looks at it and it says no label, and that's okay here because we've got this V, and that stands for VRF, or VPN V4 VRF, right? So he can see that, okay, what do? I'm going to dump that label and I'm going to send it out to 192.168.39.3, right? And you can see where it ties in here with customer A. And then the packet goes out to customer A. So a couple things that we're going to cover in the final video. We're going to set customer B up, right? I'll clear this out. So if the final video, part 3, we're going to set customer B up so that you can see what it looks like when you have multiple VRFs instead of just the one that we have right now. And then we're going to talk about some customizations that might be made by your provider to mask what is going on in their MPLS cloud so that you don't see the label information when you run your trace, right? Okay, so hopefully you enjoyed this video. Again, this is the second video that we talked about setting up the PE to CE routing protocol. We used BGP for customer A. We talked about the VRFs, remembering that VRF definition is the new format. IPVRF forwarding, that is the legacy format. That is IPv4 only. We also talked about the labels. We did a packet walk and looked at the labels. We saw that the provider edge routers, that there'll be 2 labels on there, and that bottom label is going to be the VPN V4 label that tells the PE router this is the VRF into which this traffic is going to be placed, and then from there it's based off that VRF routing table as to what's going to happen with that traffic. And so again, the final phase of this video will be setting up customer B, and we're going to use OSPF, and you're going to see that it gets very complicated with OSPF, much more difficult than when you're using just BGP for the PE to CE routing protocol. And then we're going to mask the transmission of the labeling inside the provider core, but we're going to make sure that if the provider's doing the tracing, that they do see that information. All right, thanks for watching and have a great evening.